Let's talk about data partitioning in this lecture. Data partitioning refers to a process of splitting a dataset into subgroups. Throughout this semester, what we have been doing is, when we get a source data file, we use the entire data to build an analysis model. This analysis technique has a weakness. Data are valuable. They are difficult to get. If we use the entire dataset to build a model, we don't have any data left to validate how accurate our model is. So in practice, what we usually do is we split the entire dataset into two subgroups, the training dataset and the validation dataset. The purpose of the training dataset is to use this subgroup to build an analysis model. Then we want to use the validation dataset to test how accurate the model we built from the training set is. The process of splitting the entire dataset into two subgroups is called data partitioning. In this lecture, I want to show you how to use the R software to perform data partitioning. You have several options to perform data partitioning, but a very frequently used technique is called oversampling. I want to use an example to show you how to perform data partitioning by oversampling. Let's take a look at the example first, and then I will talk about the procedure of performing oversampling. In this example, I collected the customer's willingness to pay in a mobile app. I collected independent variables such as incomes, gym visits, which state the customer is from, how long the customer used the mobile app. More important, I create a new column called Pay or Not. In this column, if a customer would like to pay for a mobile app, I mark yes. If she doesn't want to pay, I mark no, and so on and so forth. I did this survey among 100 customers. So totally, I have 100 data observation in this dataset. I uploaded this dataset to eCollege. Also, you can download it from this video's description section. Let's use this example to perform data partitioning in the R software. The oversampling technique follows certain procedure. First, we need to count the number of success cases in the original dataset, and then we want to randomly assign half of the success cases to the training set, and give another half of the success cases to the validation dataset. In our example, the success cases should be the customer who would like to pay for the mobile app. In the pay or not column, the answer should be yes. This is considered a success case. First, we need to count the total number of yes answers. How can we do that? We can either use Excel or the R software. For the instructional purpose, let's use Excel. Let's click the Pay or Not column. Let's click the title row, and then click Data, and then turn on the Filter function. And then what you want to do is to click the little triangle on Pay or Not, this filter, and then sort A to Z. You want to group the customers with the same answer into the same group. Now you can see customers who said no are grouped together. If you count the number of no answers and yes answers, you will find that 28 customers in our dataset said yes. You can count the number here. 28 of them said yes. So for the first step, we want to give half of the 28 to the training dataset, another half to the validation dataset, which means 14 of the data records with yes answer should go to the training dataset, another 14 should go to validation dataset. Pay attention to the keyword random. We must randomly select 14 and then give this 14 to training. Randomly select another 14 and then give this random selected 14 to the validation. The reason is we want to reduce bias when we build the model and validate the model. This is the first step. And then we want to look at the training data set. We move to the second step. In the second step, we want to randomly select some cases from the failure group and then give them to the training set. In our case, the data records with no answer form the failure group. The number of failure cases given to the training set should be as same as the number of success cases in the training set. We already have 14 data records with yes answer in the training set. So we need to randomly select 14 data records with no answer and then give these 14 no data records to the training set. Some classmates may have a question. Why do we want to form a training set like this? Think about it. What we want to predict is if a customer wants to pay for a mobile app or not. In an ideal scenario, we should get half of the customers who would like to pay, another half who don't want to pay. So in an ideal scenario, we should form a data set with 50% success rate, another 50% of failure rate. But if you look at our original data set, among 100 customers, we only have 28 customers who said yes. If you use the original data set to build a predictive model, your data records are overwhelmingly dominated by the no answer. If you build a model based on the original data set, your model is basically biased. That's why when we split the data set, when we build the training set, we want to build a data records with half of the customers said yes, another half said no. Totally, we should have 28 data records for the training data set. 14 of them said yes, another 14 said no. And then we can move to step 3. In this step, we focus on the validation data set. One requirement for this data set is the success rate of the validation data set should be as same as the original data set. Why is this? Because the purpose of a validation data set is to validate if our model works in practice. That's why we want to form a data set with the same success rate as we did in the original data set. What is the success rate in the original data set? Among 100 customers, only 28 customers said yes, so the success rate in the original data set is 28%. When we form the validation data set, the success rate in this data set is also 28%. Don't forget, what we discussed in step 1 is we give 14 data records with the yes answer to the validation data set. So how many failure cases we should select for the validation data set? The answer is 36. We should randomly select 36 data records from the no group. Why is that? 14 plus 36 equals to 50. If we use 50 to divide 14, that will give you 28%. Totally, we should have 50 data records for the validation data set. 14 of them are from the yes group, 36 of them are from the no group. This is how we form the training set and the validation data set when we use oversampling. Let's talk about why this technique is called oversampling. Notice that the success rate in the original data set is only 28%. But when we form the training set by using this technique, we subjectively increase the success rate to 50% for the training set. It's like we loaded more success cases than they are in practice. So that's why we call this technique oversampling. Next, I want to show everyone how to use the R software to perform data partitioning by using oversampling. First, let's download the source data file. It's called fitnessapp.log.csv. You can download this data set. in this video's description section. And then we want to create a variable in the R software to hold the source data. Let's call this fitness. Now fitness, this variable, holds the entire data set. Next, I want to create another variable. I want to call this fitness paid. I want to hold all data records with a yes answer because I want to randomly draw from this group, right? So let's call this new variable fitness paid. This is what I want to do to select all data records with a yes answer. First, let's type in the variable that holds the entire data set. And then after fitness, we want to type in a set of square brackets. And then between square brackets, I want to type in fitness again. After fitness, type in a $sign. This means I want to access to the vector inside of a fitness data frame. Which column holds the yes and no answer? Yes. The vector name should be pay or not. So I want to type in pay or not. And then after this vector name, I want to type in double equal sign. And then two double quotes. Between two double quotes, I want to type in yes. And then between the double quote and the ending square bracket, I want to type in a comma. By doing this, we can select data records with a yes answer from the original data set. Let's press enter. Let's take a look at fitness paid. As you can see, all data records in the pay or not in the fitness paid variable are yes. If you want to take a look at how many are selected in this group, if you want to see how many data records are selected into this group, you can use the function called nrow, N-R-O-W. And then between parentheses, type in fitness paid. As you can see, 28 records with the yes answer are being selected to the fitness paid variable. We can do the same for the non-paid group, right? Let's create a variable. Let's call this fitness not. Fitness not. And then I do the same. I use fitness and then a square brackets and then fitness again and then $sign. And then pay or not. Two equal signs and then two double quotes. Between the two double quotes, I want to type in no. And then a comma between the double quote and the ending square bracket. Press enter. Let's take a look at fitness not. You can see all data records are with a no answer. If you want to see how many of them are grouped together, you can use nrow. 72. This is exactly what we saw in the original data set. Let's build the training set. The training set consists of two parts. 14 data records are from the yes group, 14 are from the no group. So let's build them one by one. I want to create a variable called fitness train.yes. This variable will hold the 14 yes answer. This is what I want to do. I want to type in fitness paid because I want to draw 14 out of this group, right? After fitness paid, I want to type in a set of square brackets. Between square brackets, I want to use a function called sample. The purpose of sample is to draw certain number of data records from a group. sample, and then a set of parentheses. Between parentheses, I want to type in a function called unrow. We used it before. After unrow, I want to type in another set of parentheses. In the inner parentheses, I want to type in fitness paid. And then between the two parentheses, I want to type in a comma. And then I want to type in 14. What this means is I want to count the number of data records in the fitness paid group. And then out of this number of data records, I want to use the sample function to draw 14 of them and randomly draw them. And then between the parentheses and the ending square bracket, I want to type in a comma. I want all the vectors for these 14 data records are selected and then give to the fitness_trend.es variable. Let's press enter. Let's take a look at fitness_trend.es. And these are the 14 data records selected from the yes group. Look at the ID number for these records. They are random. This is what we want, right? Very good. Next, let's build the no answer for the training set. Basically, we can bring back the comment we used before. Let's bring back this comment and then make some modification. First, let's change the variable name from yes to fitness_trend.no. And then we want to change the variable we want to access to from paid to fitness_not. And then in the inner parentheses, change fitness paid to fitness_not. And then press enter. Let's take a look at fitness_trend.no. You see, these are the randomly selected 14 records from the no group. Next, we want to combine these two data records into the training set. We want to use the rbind function. Let's create a variable called fitness_train. This is the final training set we want to build. And then let's use rbind. In the rbind function, we need to use fitness_train.es and then a comma, and then type in fitness_train.no. Press enter. Let's take a look at fitness_train. These are the total 28 data records for the training data set. Half of them said yes, another half of them said no. Then you can use logistic or decision tree or some other models to build your analysis model. This is how you form the training data set. We can repeat the same process and then build the validation data set. Let's bring back the comments we used. First, let's change the variable name from fitness_train to fitness_valley. fitness_valley.yes. For this one, we need to randomly draw 14 records from the yes group. So this is the validation data set. And then we need to modify another comments we used. Should be fitness_valley.no. And then from this group, for the validation data set, we need to draw 36 of them. And then we want to combine valley.es with valley.no. Let's create a variable called fitness_valley. And then in this case, we need to combine fitness_valley.es with fitness_valley.no. Let's take a look at fitness_valley. This is the validation data set we built. 14 of them are yes answer, 36 of them are no answer. And then after you build the model from the training data set, you can use this validation dataset to test how accurate your model is. This is how you use the R software to perform data partitioning.